So first, let's draw our problem, which is Lulu the lunatic is going to jump over a huge bridge. And make it across the ledge. So, what speed does Lulu can make across this ledge? This is some sample questions. Cross. Okay. The height of our ledge we know the height of our platform. We also know the length of the platform as well. This would be height 2. And the height of the platform is 30 meters. Height 2 is 5 meters. And length is 60 meters. Alrighty, so instantly we can project this here and get the length, which Lulu the lunatic is going to be falling. This is height final, let's just say. So height final would equal height minus height 2, which would equal to 30 minus 5, 25 meters. Alrighty, let's start filling in the problem. So we have to get our axis established. And to do that, we will draw a little axis. So we can isolate this problem into two different problems. One problem is going to be in the y-axis. What affects us in the y-axis? Well, definitely gravity, as Lulu the lunatic is going down at this point. So she is definitely affected by gravity. And since there's no more external forces, that is the only force affecting them, him or her, in the y direction. So this is constant acceleration problem. problem number 2 is going to be Lulu the lunatic going this way, traveling in the x direction. Now, the only thing affecting Lulu the lunatic traveling in the x direction is his velocity, so his v initial. It's going to be the same right here, as well as the same here. So this is constant velocity problem. Now I like to draw these out together. I don't like to solve them separately because we will be borrowing values from one another to help us untangle this problem. So in this case, we have our velocity, which is, I'll give you, oh no, all right, that's right. What's the speed? What's the velocity that he needs to make it over? But we do know some stuff. And we know that the change in x is going to be our length, which is 60 meters. We also know for constant acceleration part of the problem that here change in height, which is change in x as well, if you consider this to be the location, equals height final, which we acquired here, which equals to 25 meters. Alrighty. So, which axis is going to control how long it takes for Lulu to fly up in the air? Well, it's definitely going to be the constant acceleration problem. Because as soon as Lulu hits the ground, here, time is going to stop. In the x direction, nothing is affecting it. He could go in the x direction forever. But the deciding variable, whenever the time of flight ends, is in the y-axis. Alrighty. So let's figure out how long it takes him to travel 25 meters going at g, downwards. So we can use this formula. and we want to solve for velocity final, this variable right here. Our velocity initial, at this point, is going to be 0 because he is riding on concrete right here. So we don't care about this part. And in order to get rid of that, square root, so we do that. Alright. Our x is going to be here, height final, 25 meters. Because that is our destination, essentially. Our x initial, here, let's set that to 0. So this part falls out as well. And we're left with square root of 2a times x equals velocity. So it is square root of 2 times 9.81 meters per second squared times 25 meters equals, let's get our handy dandy calculator. Square root 2 times 9.81 times 25. 22.147 meters per second. And that is the velocity in the y direction. Final. Well, alright. So now, since we have our velocity final here, so in y final is going to be 2.147 meters per second. We can figure out how long it took for him to travel such distance. We can use this formula here. X equals 1/2 of velocity plus velocity initial times time plus x initial. Well, our x initial is 0 right here. So that falls out. We want to solve for t. So we just simply two here. These twos cancel out. And we will divide velocity over velocity initial. Well, our velocity initial is 0 in the y direction. So this term falls out. We're just left with velocity, which we know what our final velocity is from right here. We just got it. 2.147 meters per second equals time. And our x is going to be the change in x, or the height f, 25. So we can sub that to be 25 meters. Oh, I would like to notice as well that these meters here end up being squared, and the square root removes one of the meters as well as one of the square of the seconds, which gives us our units perfectly fine. In this case, meters cross out with meters, leaving us in seconds, which travel up. We have time in seconds. So let's put that in the calculator. And we get that it took 2.25 seconds. That's how long we're traveling in the air. That's a really important part of this problem. That means that to get to this point, for Lulu, took change in time equals 2.57 seconds. With this information, we can see how long we have to fly in the air for such a gap. So we want to clear this whole gap, right? All right. So what our velocity has to be in order to clear this gap? That's what we're trying to find out. We have the time, which is very important. Change in time, seconds. So since we have the time, we can plug and chug another one. I guess we can use this one. Okay, so this is separate these. So don't get confused. X equals 1/2 of velocity. Since velocity is the same, I'm just going to leave it as velocity and get rid of this times acceleration. x initial. Our x initial is 0, so that goes out. So its velocity times acceleration should equal to x. We know our x is 60 meters. So it's going to be x divided by time equals velocity required for us to make that jump. Alrighty. So 60 meters divided by 2.57 seconds equals 26.57 meters per second. So you notice our units came out perfect as well. So that's how fast Lulu the lunatic has to travel in order to clear this gap. So velocity initial 26.6 meters per second. And this is answered. Alrighty, what about, I asked a question, what angle is Lulu the lunatic coming in, and what speed? So this is going to be a vector problem, construction problem actually. So from the previous answers, you can see we have velocity in a y direction. This is velocity in the x direction. It doesn't change. There's nothing stopping it, and we are ignoring the air resistance as well. So velocity in y (22.14 meters per second). Velocity in x is 26.57 meters per second. Let's construct a triangle. And as you see, I'll look at my problem, and since Lulu is approaching this way, I know that the vector is going to face this way as well, so I'm constructing my triangle the way it makes sense in the picture. So we're trying to figure out the magnitude and the angle. In a y direction, this leg of the triangle is going to be 22.14 meters per second, and this one is going to be 26.57 meters per second. So we will simply use Pythagorean and solve for it, which is going to be 22.14 squared plus 26.57 squared equals 34.86 meters per second. Alright, so what's the angle of this, of the impact? This is our magnitude. So the angle is going to be we want tangent. So we'll do sine. Sine is opposite over hypotenuse. So sine inverse theta equals 6.57 over 4.86. We're in radians, that's why. Always make sure you're in degrees, or else the answer's not going to make any sense. Sine 26.57 over 34.86, just 49 degrees. Degrees. Now, since we are reporting in degrees such as these, we have to make sure that we give it direction. So this is going to be 49 degrees going this way. So east of south. We are going towards east from south. So our complete vector impact is going to be 34.86 meters per second at 49.6 degrees east of south. Pretty much found everything we could possibly want from this problem. We figured out how fast he needs to go in order to clear the gap. You can use it for skateboarding or whatever else you want. See you next time.